All right, in this lesson, we're going to be looking at mid-segments of triangles. So a couple things that we need to remember when we're dealing with mid-segments of triangles is that there is a rule, there's a theorem. And what it says if we were to take, for instance, in this triangle, if we were to take D to E, and notice that this is a mid-segment of a side of a triangle, right? Because notice that this bar right here that you see on each side represents that this is half the distance. So this line segment is equal to this line segment, and this segment of the triangle is equal to this segment. So therefore, these are both what we call mid-segments of a triangle. And if we wrote this out mathematically real quick, we could say that DE is going to be equal to 1/2 of AC. Now, another way that we could look at that as we're writing this, and these are line segments, is we could say that DE, line segment DE, is going to be equal to AC divided by 2, right? Because multiplying something times 1/2 is the same thing as dividing it by 2. And I typically like to look at it like this right here. Now, we could also, we can go the opposite way. Another way that you could look at this is you could say, because notice in this particular problem it gives us DE, right? We could say that if we multiply DE by 2, in other words, I'm going to write this out, 2 times DE is going to be equal to AC. So I don't know which way it's easier for you to understand, but all these say the same thing. And the main thing I want you to remember is that the smaller line segment, right, the smaller mid-segment, is going to be double the larger. So that's hopefully what you take out of this. Now what I'm going to do is, notice it tells us to find x. It said solve for x in this example. So we're going to solve for x, and we're going to use what we see here for the value that we see in DE to do so. So when I set this up, this is the way that I want to set it. I'm going to go ahead and I'm going to write 9 is equal to x, so there's my variable x, divided by 2. Now, once we set this problem up, and this is actually using this ideal right here, right, this theorem, so segment DE is equal to segment AC divided by 2. So x represents the segment A to C, and I'm just going to highlight it real quick. And so if I wanted to solve this, I would use inverse operations. And my first step, I'm going to rewrite it because I'm going to change some things, right? That's just how I set up the problem. My first step is I want to get rid of this 2 in the denominator. And the way we get rid of it, notice this is x being divided by 2. So I do the opposite of dividing x by 2, which is multiplying x by 2. Now, if I multiply the right side of the equation, remember when in algebra when you did equations, you always got to keep it balanced. It means we also have to multiply the left side of the equation. Now, anytime that we multiply a fraction by its denominator, they just cancel, and all we're left with is the numerator. So x equals. And then if I multiply 2 times 9, that gives me 18. Therefore, my answer is x is equal to 18. And that's how you solve it. Now there's another video. I have 3 other videos showing you 3 other examples that are slightly different. So check those out as well and see if they help you answer the questions that you have from your teacher.